Put that in here. Some of these are hard, some of them are medium, some of them are easy. This is kind of how it goes. I hope you think number one's easy. That's my hope. Number two, maybe a medium rare. I guess we'll do two of those. I don't know if I want to spend time on that.
So, with the X being right next to it, that just means F of G.
Yeah, we'll skip that one. Okay, what do we do on number one? Add. What do we do on number two?
Are we going? You're just doing.
Whoops, let me do that. It's, what is three? What do we do on three? Multiply. I did not put divide on there, so. Yeah.
So on the first one, you're just adding 2x squared minus 30 to 3x plus 1.
Yep.
But why would you put parentheses?
Well, when you're adding, you don't need parentheses. It's just kind of show. Sometimes you do need parentheses, like number 3.
Like number 3, I get it. But
it's just to show the like the difference.
I know, but are we foiling them?
Yeah, 3 would be a FOIL problem, right? That times that. So on the top, remember when you're adding or subtracting, you can only do like terms, right? So 2x squared, kind of by itself. Plus 3x, that's by itself. Negative 3 plus 4, plus 1. Okay, does this make sense what I did on number 2 here? I put the g function into the f function where the x used to be. That's what that means. The g function goes into the f function. Okay, how can we simplify this? Okay, no, you have to do 3x plus 4 times 3x plus 4 first, and then times 2. This is a FOIL problem as well. I am going to do that really quickly in my head.
there's some 18.
Yes, but it's all review. Okay, anyway, and then you can do distributive property. So we get 18x squared plus 48x. 32 minus 3.
So then, when you do FOIL, do you do all of it, or you just do first and last?
First outside, inside, last, whole thing.
Okay.
You can only do first and last when it's conjugates.
And then you multiply, so the second step you multiplied everything independently. So you did 3 times 3, and then 3 times 4, and then you did 4 times 3.
Yep.
4 times 4?
Yep.
So why is there only 3 multiples?
The outside and inside were both 12x, they add up to 24x.
So you just skipped that step.
Yep, did
Okay,
my
that's
head.
what confused me.
Okay. I don't have time to really review FOIL very much, but, so the first is 2x squared times 3x, so that's 6x cubed. The outside is 8x squared. The inside is, and the last, negative 12. Now, in this case, none of these are like terms. Doesn't usually happen, but, so that's all you can do on 3.
You gotta go slower.
I gotta, if you need to go back, you have to watch it, because I have to keep a pace here. Make up a few things here. Okay, so what do we do to find the inverse? This is swap the x and y values. That's all you do. So this should be one of the easy ones. As long as you know what to do. Should take 0 brain power. Is that a function? I didn't write that question down, but yes, it is. All the x's are unique. Okay, and now the trickier version. Let's do 3/4 x minus 1. Okay, so
What did you write yes next to number 4?
yes, it is a function.
How do you know if it's a function or not?
If there aren't any repeat guesses.
And by x you mean like the things like
The x
The
the 0
first.
to the, oh, you mean the first one. Okay.
Graph both. Are they functions?
What the heck just happened?
Okay. How do we find inverses?
Switch the x and the y.
Switch the x and the y value. So the f of x is like the y, so I'm going to turn it into the x. And the x turns into a y. Okay, and then we solve this for y. How do I get y by itself? Plus 1. This is kind of where things went wrong, I think. Like on, what number was it, 18 or something like that. How do I get rid of the 3/4? You divide by 3/4, which is like multiplying by 4/3. So yeah. If I multiply by 4/3, I just get 4/3 x plus 4/3. You guys get it? So dividing by 3/4 is like multiplying by 4/3. So the inverse function is 4/3 x plus 4/3.
I borrowed it. You need it? I gotta use mine.
And then we're supposed to, so we gotta make our own graph. I'm not gonna hand out graph paper for this one, just make your own graph. So the original function, remember how to graph these? We start down 1 and we go up 3 and over 4. 1, 2, 3, 1, 2, 3, 4.
How did you, or what's that thing on the left of x plus 1? Is that 4 over 3?
Yep.
How did that even come into play?
Divided by 3/4 is multiplying by 4/3. Divided by 3/4 means multiplying by 4/3. Okay, on this one, the y-intercept is 4/3, which is 1 1/3. Right there. And the slope is also 4/3, so I'm going to go up 4, 1, 2, 3, 4, and right 3. Down 4, up 3. Kind of slowed across here. Whoops.
Is that because it's in the B?
I'll try again. Oh, I erased my dot. 1, 2, 3, 4, 1, 2, 3. Kind of wish I picked different numbers. Looks something like that. Slope is rise 4, run 3. Remember, it should be a reflection over the diagonal line, y equals x. Okay, are these both functions?
Yes. Yes.
Yes and yes. Lines are always functions unless one of them is, unless it's vertical, and that's not a function. It was the parabolas that the inverse was like not a function, right? That was the problem.
There's so much going on in that. Actually, no, I'm not supposed to do it.
Okay, then we're gonna move on to logs, lots of logs.
Action is true.
Oh, I forgot to tell you guys. Number 1 on the test. I kind of didn't write it down, so I'm going to go back and write it. What number are we on? Number 6. We'll call it number 6.
Label.
You guys have this one in your heads yet?
Yeah.
No?
No, I did not.
PLC1. Dude.
Just do it quietly for now, and then we'll...
Seriously, Will. I thought you were asking for
Is that not it right there?
I was just asking if you had it.
Question. Question on the board, Will.
I was asking for a yes or no, not the answer yet. Okay. These are actually number 1 and 2 on the test right here. Kind of. Yeah.
Is that it?
Yes. Okay, but you have to have it memorized.
A
Also,
times T
it's 80.
equals P. Okay, sorry.
So, if we're just saying like this is increasing by 3%, that's when you use the exponential growth formula. Or if it's decreasing by 10%, whatever it is. But when it says is compounding monthly, compounding daily, what changes?
It's R over K and then K times T.
Yeah, there's a R over K and a KT right there. So So this is one of those things where you'll do it at the beginning of the test, and then I'll grade it. That way if you get it wrong, you can still use it later on when we use those formulas. So probably what I'll do is I'll just walk around and grade everybody's and then rewrite it on the board so you can use it.
What the heck is that?
Okay, it's just right there. What to do on this test. I gotta write it down first. I can't stand to the side and write on the whiteboard. And what made you think I would be concerned about that?
Body.
Now look at your paper.
I don't think you can.
Okay, I hope 8 and 9 aren't hard. We've got a lot of them, but you might not have them in your range yet. So it's ACB, yes, is the order. So 8 you should make look like 9, and 9 you should make look like 8. That's what we're doing there. Like something or something.
More calculations, more problems you would solve in there.
Here's this, Mr. Jordan.
No, they don't shoot it.
You
What
said
about the trash?
dude.
No,
He literally said.
Passing those back.
not right now. Okay. So, I was just working on it a little bit. It's ACB, so it's log. You put a little number first, little 5, and then the last thing.
Oh, what if there's like a
Oh,
equals
that was
to
that
me.
on 5. That's a 3.
Sorry. No, I wrote it right.
It's the one above 8.
Oh, wait,
I was
I
thinking you did 9.
And then
Silly me.
Yeah, so the first number is first, and then the third number, and then the second number. Okay, and then on the logs, to change it to exponential form, it's 3 to the 4th is 81. You can kind of tell because it's true, 3 to the 4th actually is 81. All right. Moving
What
on.
about 10?
That's also 10.
What happened
Yeah,
to 10?
where's 10?
I'm used to counting by odds.
Wait, Mr. Jordan.
One should never get comfortable and doesn't have to worry.
Okay. There's. I did put a couple of these ones on here. Whoops. Well, what do you think that means?
Find the answer?
Okay, it means plug it in. Evaluate just means plug it in, okay?
Mr. Jordan, what's up, February?
No, you're not, you
the
Trevor.
guy
So lunchtime and
We had like 10, 12 minutes. I can wait. I watched water boil for 10 minutes today, so.
It probably not that.
ours got longer.
Ours didn't even what?
I can find it.
Didn't know.
Yeah, ours took more like 11 to 12 minutes.
We threw it away.
Wait, is the A in the log?
It was goofy. And then like it threw it
Hmm?
Is
What?
the A like in the log?
What guys, what's going on?
Talking about this?
Yeah. Is it like in the base or is it?
No, it's a normal A.
Okay.
The base is invisible. Well, it's
I'm
10.
sorry.
Okay, what did 10 come out as? You guys plug it in?
Yes.
What did we get?
8.
8. Okay. Do you guys remember how to break apart logs?
Yes.
Just do log A.
No, I do.
Log to,
Okay,
log.
yeah. When they're multiplied, it's a plus. So it's log of A plus log of B squared. When the exponent
Yeah, you can move it.
can move down in front though, so it's log of A plus 2 log of B. Alright, what do we do with subtraction? Divide.
So log of A divided by log of B.
You just A over
B is 1/2.
Shoot, I don't want to do that on this one. Let's do, yeah, let's do like, yeah, that's fine. Thank you. So, yeah, it's just log of A, well, no, not quite. That would just be log of A divided by B cubed. Okay. Just, so there's 3 rules. Multiply turns into adding, or adding turns into multiply. Subtraction turns into dividing. And then if there's an exponent in front, or the exponent can move to the front, or it can move back up. Alright, anyways. 13. No. Okay, we're rounding to the thousandths place. Okay, so in general, what was the rule? When you have a log equation that you're trying to solve, what was the rule?
Get that
Change it? No.
Change it to,
Change it to exponential form.
Oh, yeah.
So log x squared equals.
no, it's x squared equals.
Yeah, just check that though. Square root. Supposed to round.
I'm gonna move this to 15. Like 14, something else. That'll come out weird, but whatever. Mm.
This is where it gets confusing. Then why did you make an erasing line?
Let's do.
Why is there a dog? Let's get rid of it.
Using us all.
Okay. So yeah, this kind of goes back to earlier. How do I change this to exponential form?
X squared equals.
x squared equals 9. And then how do I solve that for x now?
Why can't I just
Yeah, to get rid of the square, use square root this one, yes. Plus or minus 3. Okay, if it's in exponential form, like something to the power, what do? Change it to log form. Go the other way. So what's this as a log? Log base 7 of 4 equals 2x. So this thing on the left is something you can plug in your calculator, right? But how do we solve this for x though?
Divide by 2.
Yeah, you gotta get x by itself, so you do have to divide by 2 there. Rounding to the thousandths place, which means what?
And then you cut out the 2.
Okay. What did somebody plug that in? What'd you get? Sure. 0.356.
Yeah, that's what I got.
Okay, on 15, what's different about this one?
Did you have to make the
Okay, we got logs on both sides. So on this one, we just want to kind of put the logs together. So how do I? Didn't mean to do that. Okay, let me. Okay, fine. We'll just leave it. How do we put these two together? Multiply. 3x times x. Okay, how do I put these two together? Divide. What's 80 divided by 4? 20. Okay, once you get both sides say log of this equals log of that, this and that have to be equal to make these equal. So it's 3x squared equals 20. It's going to be kind of a mess. So to solve for x, I'm going to divide by 3. And how do I get rid of the square? Well, not that version.
plus or minus 3.
Okay, you need square root of 20. Well, I guess I did say round to the thousandths place, didn't I? So I would take 2 square root of 5, or what was the decimal version?
6.6 repeating.
So the thousandths place would be 6.667.
Yeah,
Where did 3 go?
Oh, sorry. Forgot about it. That's where it went. There we go. Well, it's no longer that. The 2 squared root of 15 maybe? Over 3. But is it still?
2. Yeah.
Okay. Since the directions did say decimal, I guess I don't care to put the decimal on that one.
Oh no, we have 4 rounds.
Okay, so what remains? There is one of these functions that we got to graph. So how did we graph these in the chapter? What did we do?
You go up 1.
Well, it does make the graph go up 1, but that's not really. Okay, we just plugged in some numbers, right? Like -2 to 2. Like if I plug in -2, I would get 1 and 1/9, or a decimal, 1.1 repeating. And this would be like 1 and 1/3, and this would be like 2, and this would be 4, and this would be 10. And then there's graph on the test, so you just graph those points. You guys know what the graph should look like though? What shape? Yeah, that is one of these. Okay, also, there will be kind of one of those bear problems, like if the population is 20,000 people and it increases by, stop. If the population is 20,000 and increases by 5% every year, what's the formula? Okay, and then it'll say how many people are there after 10 years or something like that. And then there'll also be a compound interest. So, do you guys remember if you invest $10,000 at 3% interest and it's compounded quarterly?
Wait, that's 4.
4. So there will be a 4 there
4 times T.
and a 4 there. Okay, I know that's quick, but hopefully that just reminds you of what we've already done.